Hi, good day. My name is Alan Sarko Jr. from BIS IT3C, and in this video I'm going to answer the assessment 1, which is to record a video of yourself reciting the names and uses of each component of the Arduino UNO board for the subject embedded systems and programming. So for the first part of the board, we have the power USB. USB port used to load the program from the Arduino IDE onto the Arduino board. The Arduino board can also be powered through this port by using the USB cable from your computer. Next is power barrel jack. Arduino boards can be powered directly from the AC mains power supply by connecting it to the barrel jack. The Arduino UNO board can operate at a voltage of 5 volts, but it can withstand with a maximum of 20 volts. If the board is supplied with a high voltage, there's a regulator that protects the board from burning out. So next is the voltage regulator. It controls the voltage given to the Arduino board and stabilizes the DC voltage used by the processor and other elements. And what as I said earlier, if the voltage supplied to the board is higher, then there's a voltage regulator that protects the board from burning out through regulating the voltage circulating inside the board. So if magawa ni siya na chance nga madaot ang imong Arduino board tungod sa high voltage nga na pwede nakasod nga pwede makasulog sa uban parts sa board. Next is crystal oscillator. It helps the microcontroller to calculate the time. The time plays a vital role in receiving and sending signals to peripherals and physical devices. Based on the oscillator frequency, the microcontroller is able to take speedy decisions. Importante ning crystal oscillator is because siya ang nag-provide og clock sa microcontroller. And sa microcontroller or microprocessor nato, tanan instructions gi-execute with synchronizations of the time. So if maguba ni siya or ma-remove nato, there won't be any kind of machine cycle generated sa atong microcontroller and ang instruction won't be executed. So that is the use of crystal oscillator. 5 is the Arduino Reset. As you can see in the 5 and 17 number, it is used to start program from the beginning. You can reset the Arduino UNO board in two ways. First, by using the reset button on the 17 on the board. Second, you can connect it to an internal reset button, but in a pin labeled reset as you can see in number 5. Next is pin or the pins. As you can see in number 6, it is the 3.3 voltage supply output volt. 7 is the 5 volt supply output volt. 8 is the GND or ground pin, which can be used to ground your circuit. It is sometimes called the return because all current loops end at ground and the current returns to the battery or supply. It is where you measure most voltages from. So that is the use of ground pin. Next is the VIN pin. Also can be used to power the Arduino board from internal power source like AC mains power supply. So that is for the pins. 7 is the analog pins. These pins can read the signal from analog sensor like a temperature sensor and convert it into a digital value so that the system understands. These pins just measures voltage and not the current because they have a very high internal resistance. Hence, only a small amount of current flows through your through these pins. Next is the main microcontroller. Each Arduino board has its own microcontroller. As you can see in the number 11, you can assume it as the brain of your board that allows you to program your Arduino in order for it to be able to execute commands that or decisions based on the code you made. So just like the motherboard, the CPU is also referred as the brain of the computer. The microcontroller used on the UNO board is Atmega 328P by Atmel, a major microcontroller manufacturer. Atmega 328P has the following components in it. First is the flash memory of 32 gigabytes. The program loaded from Arduino IDE is stored here. Next, the RAM or random access memory of 2 gigabytes rather. This is the runtime memory. Next is the CPU, Central Processing Unit. It controls everything that goes within the device. It fetches the program instruction from flash memory and runs them with the help of RAM or random access memory. And last part of the at Mega 38P is the electrically erasable programmable read-only memory or EEPROM of 1 gigabytes. This is a type of non-volatile memory and it keeps the data even after the device restart and reset. So that is the main microcontroller. Next, the ICSP pin, as you can see in number 12. These pins are used to code and boot an Arduino from an external source. These pins allow to enter workings of 2 or more Arduino boards and also allow you to upload your firmware. The ICSP pins acts as the AVR programmer, which is used to code or boot the Arduino. So next is the power LED indicator. So as you can see in number 13, so simple, this LED should light up when the Arduino board is powered correctly. But if not, there might be something wrong within the connection and time to recheck your circuit. Next is the TX and RX LEDs or RX LEDs. TX is short for transmit and RX is short term for receive. So the TX LED flashes with different speed while sending the serial data. The speed of flashing depends on the baud rate used by the board. The baud rate signifies the data rate in bits per second, so that is the baud rate. RX flashes during the receiving process. Next is the digital I/O or digital input output. You can find these pins labeled digital 0 to 13. These pins can be used as either input or output pins. When used as output, these pins act as a power supply source for the components connected to them. When used as input pins, they are signals from the component connected to them. So when the digital pins are used as output pins, they supply 40 milliamps of current at 5 volts, which is more than enough to light an LED. Some of the digital pins are labeled with tilde symbol, as you can see in the picture. To the pin numbers are 3, 5, 6, 9, 10, and 11 have this symbol. These pins acts as a normal digital pins but can also be used for pulse width modulation or PWM, which simulates analog output like feeding an LED in and out. So that is the digital I/O. Last but not the least, RF or RF stands for analog reference, and most of the time you can leave this pin alone. It sometimes used to set an external reference voltage between 0 and 5 volts as the upper limit for the analog input pin. So that's it for this assessment and parts of the Arduino UNO board and its uses. Thank you.